Okay, we can start now. Welcome again to everyone. Today we are giving some details about your speakers. It's myself. I'm Andreas Palermo, working in GMI since 2015. I have 20 experience in automation, machine process market. And now I'm responsible for major account for seal application and ATEX applications. I'm a functional safety engineer. And we have also Massimo Pagani, is our product manager. And Massimo has a long experience in technical support and more than 20 years experience in electronic products. He's also functional safety engineer. He's responsible for also customer support within GMI. So if you have any special question for him, he will be available for you today and the next time, of course, next days, if you have any question. And we want to give you some details about GMI, just a short overview. What is GMI? GMI is a product company that design and produce seal certified devices with intrinsically safe solution for the process automation, such a PLC DCS application, requiring additional features for all dedicated certifications, like such ESD, fire and gas, BMS, IPS, and so on. We are concentrating industrial fields such oil and gas, petrochemical, pharmaceutical, mining, food, fertilizer, and so on. 40 years experience, founded in 1993. And we have our internal production, which is near Milan, 100% produced in Europe. It's a family-owned company with a global player and presence in 5 continents. The product range is this one. So we produce IS barriers, safety relays, isolators, safety with the seal certification, seal power supplies, multiplexer for temperature digital signals, termination boards, HART multiplexer, surge protection indicators, and also we provide functional safety and EX trainings and services. And this is, product that, tested and certified by over 50 independent agency laboratories, TÜV, certification available for different market applications, Europe, America, Korea, China, India, Russia. We have also functional safety management, seal-free systematic capabilities for the design for the product, because the seal certification is not any longer valid if it's not supported by systematic capability certification. Over 10% of our employees dedicated for research and development or for innovating products. And we also provide 5 years warranty for the products. As we say, we produce completely in Italy, complete traceability, full testing, very automated process. That's the number about the GMI. We have a presence in all continents, different distributors, total staff, courses per year, and number of installations. The last, and then we go to the topic for today, is the reference list of the name of our customers, major customers. So we will finish this part, and then we have this poll. If you want to answer to this poll very briefly, so we know what kind of customer we have today in front of us and what is important certification for the SAR application. I see that is very important for you. Very good. Okay. Few seconds, let me stop this poll. If you want to answer, please do it now. Okay. Perfect. You can stop. Thank you. Now is your time, Massimo.
Okay, thank you, Andrea. Thank you for your introduction, and welcome to everyone also from my side. This GM International webinar dedicated in its first part to the smart relay and their real application. Well, we can start with our presentation. Let's start by introducing the concept of SIS, Safety Instrumented System. SIS is a set of subsystems that make up the safety loop. Within this safety loop, we have field devices such as transmitters or sensors, which allow us to control, detect, and measure variables in the field, such as temperature, pressure, or other. They are driven by barriers or isolators that provides for limiting the current toward the hazardous areas or to isolate field instruments. And in turn, the signals sent by the field loop will be acquired, managed, and interpreted by what is the brain of the SIS or the PLC DCS system, which will decide on any action to be taken to make a plan to save. And again, power interfaces as can be a safety relay, which will then act on a valve on the external actuator, which allow us to bring the system safety in case of need. The main concept that needs to be understood is that every single element of a SIS must be sized with a seal level, such as to allow us to obtain the overall seal of the SIS required. All components of a SIS, including power supplies, to which we will dedicate a part of this presentation, must be safety related and have a seal level. This helps us to have a safety loop, and with the correct redundancy, a loop with high availability to the process. But let's start examining those that are a fundamental part of a SIS. Let's talk about safety relay. A safety relay can stop or initiate a movement in a controlled, safe manner by opening, closing valves, start-stop motor, and so on. They must conform and adhere to the ESC 61511 industrial standard, and not only for oil and gas or process industry, but in general, a safety relay can be used where a failure of a relay can cause serious accident to human, environment, assets, or image. Well, but what are the typical cases where a safety relay is required? So typically, we must use a safety relay in all of those applications where the controller, the digital output card of a PLC, for example, is enabled to activate a field device due to its limited potential in relation to the voltage and current involved. Or in those applications where multiple contacts for the simultaneous activation of multiple loads is required. Or again, even in those applications where the safety function that the controller must perform needs to be inverted. But what is the difference from a standard to a safety relay? Please, Andrea, it's your turn.
Okay, thank you, Massimo. Just a reminder, if you have any questions, just push our Q&A button on your bar. You can write your question. We try to answer to all doubts during this webinar. Okay, standard relay. We say that the standard relay cannot be used in a SIF, so you cannot use a standard common relay in a SIF because that is not certified first. Okay, but beside the certification, let's say the certification itself is depends that a specific party is able to perform a safety function. In this case, the relay is certified that is able to perform that function with a very high probability. Okay, so the safety function in this case is aimed to reach a specific safe state on demand. So open the valve or activate the fire extinguisher system and the same. So it's very simple functions, but it must be really granted that possibility that the device is able to perform it. So most of the time is we are talking about ESD applications, so IPS, BMS, and the safety function is normally energized. So you want to de-energize to safety, so DTS, de-energize to safety, or de-energize to tree. That is open on demand. In firing gas application, the safety function normally is normally de-energized, so want to energize to safety. ETS, E2, ETT, energize to tree. Those are the very simple functions. And coming back to the initial things, a standard relay is a relay that is not, of course, can do it, but you never know what is the probability that that relays will be able to perform it, that function. So just to give you more details about that, we are talking about components. So for determining the cell level of the components, there are several parameters that are included in the estimated calculation, estimated analysis, failure-made and diagnostic analysis, that and all components inside, you see from this table, are included to the FMEDA, and for each component there are some values that are provided by the manufacturer for the components, and declare some, especially the failure rate. And failure rate can be failure rate, we're talking about safe failure or dangerous failure. And within safe failures, there are safe, detected, safe, undetected, but are always safe. And within the dangerous failure are dangerous, detected, dangerous, undetected. You understand that the dangerous, undetected are the most complicated things because they are dangerous and undetected. So that is the critical part, and of course must be included in this calculation. And therefore, all components give made a thought analysis for the product that claim to be safe. Okay, now is I leave Massimo this part. Okay.
Thank you, Andrea. Well, let's look specifically at the difference between digital input relay and digital output relay. Digital input relay are those devices able to managing a voltage-free contact positioned in the field and communicate the status of this contact to a digital input card of a PLC DCS. A typical example is a proximity sensor, NAMUR type, which is fed and acquired through a galvanic isolator for digital signals. In this case, the sensor in the field is a simple contact free of voltage, which needs to be read and interpreted by our device, digital input relay in this case. But what happens if in the field we have a wet contact by a voltage, which can differ in values such as 48 volt, 230 volt, 24 volt DC, and so on. In this case, a digital input relay cannot be used because its input front end is not available to accept external voltage from the field. In this case, we will have to use a digital output relay. That is a device that, depending on the voltage that arrives at its command, activates or deactivates an output contact and communicates to a PLC DCS the presence or absence of a voltage in the field. The classic example could be the one where we need to communicate two PLC DCS systems placed in two different contexts. The digital output card of one of the two systems controls our digital output relay, while a digital input card receives the contact status of the digital output relay. What may be the main problem that can be encountered using a relay for this purpose? First of all, we have to keep in mind that usually a relay is designed to switch important values of current, while usually towards an digital input system, the currents in play are very low, typically less than 100 milliamps. In this situation, we can face problem of oxidation of the relay content. Therefore, it's essential to choose a safety relay with golden plate contact, which allow us to switch, thanks to its high conductive performance, even current lower than 10 milliamps. To deal with this problem, GMI has equipped most of the relay of the new D5000 series with golden plate contacts to make them available to this particular application. In addition, GMI has developed a universal device able to receive at its input a different voltage level, 24 volt DC, 48 volt DC, and so on, selectable via the switch, while the output provides a free contact voltage, optocoupled type compatible with all PLC DCS systems, which ensures maximum conductive even at lower currents. The device is specifically designed to work in this kind of application, where we have to communicate between two systems distant from each other, or when we have two signals to a system, presence or absence of voltage. Now, let's look at the diagnostic safety relays, commonly called smart relay. This relay allows us to constantly monitor the load and the line in the field and report to our system if a fault is detected in the field. The diagnostic of these relays is active both in on-relay condition and in off-relay condition, allowing us to know the health of the loop, especially in fire and gas application. Why going for smart relays? Nowadays, full diagnostic is typically required along the full loop. However, many widespread systems do not support digital diagnostic inside their digital output cards. Smart relay make diagnostic available to systems that do not support it. In other cases, many modern systems do support digital output diagnostic. However, in many applications, they cannot directly drive the load because they are voltage and current limited, typically no more than 500 milliamp at 24 volt DC. Or when the load, valve, beacon, sounder, and so on, require more than 24 volt and or more than 500 milliamp relay are necessary. Yet, when using standard relay, the digital output diagnostic dies at the relay coils and cannot reach the load in the field. As opposed to that, smart relays can go beyond the typical voltage current system limitation while keeping the full load diagnostic. Even if modern systems can perform load diagnostics, their capabilities may be limited. For instance, a leakage monitor may not be supported, or extreme load, for example, beacons, may always be reported as an open circuit to the system. Smart relay may offer a solution to extend the digital output diagnostic capability. Well, smart relay also introduced the possibility of mirroring a fault in the field directly to the digital output card of a system compatible with this function. Let's see more detail what is the mirroring function on a smart relay. This function allows us to reflect information related to the field fault directly to the supervised digital output card of a PLC. This is in both in the off state through the pulse test system and in the on state by reading the static return of current, The digital output card of a PLC system can detect the information related to the field fault. This system, through an upward impedance variation of the relay input circuit, allows the supervised digital output to see the fault in the field. This system allows considerable saving in engineering cost, as it allows us not to use a dedicated digital input card for this purpose. For this purpose, GMI integrates its range of a smart relay with the two models, D5096S and D5096S-100. But what are the differences between the two models? Well, the D5096S is a smart relay with fixed diagnostic with the possibility of mirroring a fault in the field directly to a digital output card compatible with this functionality. This type of relay is still free for both normally energized and normally de-energized application. And the mirroring function is performed through a change in impedance. Not all PLC DCS systems are able to correctly read this impedance variation. For this reason, the D5096S-100 variant was created. The D5096S-100 has the same diagnostic functions as the D5096S, but has a universal mirroring system compatible with all PLC DCS systems, since inside the relay, it's placed in series with the input circuits, terminal 1 and 2 in the slide, the fault transistor. In this way, when a fault in the field is detected, the input circuit is opened and an open circuit is shown to the digital output card of a PLC DCS. This kind of relay is still free for normally energized application, but is still true for normally de-energized application. Well, let's see what are the diagnostic opportunities that these two relays offer towards the field devices. When the load is activated, the relay contacts are closed and it's able to monitor continuously the voltage applied to the load and the current flowing through the load. Instead, when the load is deactivated, the relay contacts are open and it's able to monitor continuously the power supply voltage and the impedance resistance and the load resistance. Well, now introduce the D5294S smart relay with fully configurable diagnostic in all its parameters. This smart relay, in addition to offering all the advantages of the smart relay seen above, adds other features such as a fully customizable diagnostic on the type of load to be used, the ability to read and write data from the model via Modbus RS485, offer an internal diagnostic on the integrity of the coil that make up the magic of electromechanical relay. And finally, gives the possibility to diagnose a leakage between load and earth. Moreover, the relay modules D5294S support Modbus communication over an RS485 cable. Up to 127 modules can be arranged in a multi-drop network and monitored or configured by a single master unit. Each slave contains tables of parameters. Each of them is uniquely identified through an address, and when requested, makes available its value for reading or writing. What are the advantages of using Modbus communication? Well, with a single Modbus RS485 interface, it's possible to connect and communicate with all the relay present on the same bus. Multi-drop connection is possible and communication can cover distance up to 1,200 meters. And another advantage is the possibility of not using a dedicated digital input card system to monitor alarms. This allows us to have a significant saving in terms of cost. And again, we have the real-time information on the type of alerts and on the health of the load on the line. It's possible to Modbus a complete remote programming of the relay. Well, in this case, what are the functionality of the diagnostic? The smart relay is able to detect the line and load fault, both in energized and de-energized condition. What can we monitor when the relay is in on state? For example, a typical application could be the monitoring of a normally energized part. Well, when the load is activated, the D5294S is able to monitor continuously the voltage applied to the load, the current flowing through the load, and also internal coil integrity. This specific model, in fact, has the possibility to performing an internal diagnostic of its coil, and in the event of a fault, report this fault to the system. What can we monitor when the relay is in the off state? Typically, fire and gas application, where we need to know the health of the field loop. Well, when the load is deactivated, the D5294S is able to monitor continuously the power supply voltage, the load impedance, and in this case, the leakage from the load to the ground. In fact, this type of relay can monitor the leakage resistance between the earth and the load. Now, let's examine specifically the typical configuration software of our D5294S smart relay. This kind of relay can be also configured when the parameters to be monitored are really specific and the alarm triggering is not achievable with standard monitor relay. It's also possible to monitor the status of the loop in real time with the configurator. Through a dedicated software called SWC5090 and a small hardware interface, we can completely configure the module. For example, we can set up a window in which the value of voltage on the load, current flow in the load, and impedance of the load are included. In this way, when the measurement of the variables in the field come out of this window of a configured value, an alarm is reported to the system. Through the configuration software, it is also possible to read in real time the value of voltage, current, and load impedance. And note that the D5294S can set impedance value between 5 ohm and 50 kilo ohm. Let's see specifically how the relay can communicate with the system. How and what are the ways in which a smart relay can communicate with the safety system? Smart relay can report the field status to the system in several ways. The first one is the two fault contacts can be acquired by a digital input card of a PLC DCS. This is the typical way, which implies the use of a DCS with a dedicated digital input card, where the status of a contact called a fault is monitored by a system. The second method, if the system digital output port drive the smart relay support bulk testing, the fault in the field can even be mirrored directly to the digital output without the need of an additional digital input card. And again, the fault on bus can also be acquired by a system digital input card. The fault on bus is normally used when a cumulative fault, cumulative report from many modules is required. And last but not least, the complete diagnostic information can be retrieved through Modbus Multidrop RS485 protocol if a Modbus master is available on the system side. Remember that through the Modbus protocol, the relay can be constantly monitored and also configured remotely. Let's see in more detail what is the mirroring function on a smart relay. This function allows us to reflect information related to the field fault directly to the supervised digital output card of a PLC, both in the off state through the pulse test system and in the on state by reading the static return of current. The digital output card of a PLC system can detect the information related to the field fault. This system, through an upward impedance variation of the relay input circuits, allows the supervised digital output to see the fault in the field. This system allows considerable saving in engineering costs, as it allows us not to be used a dedicated digital input card for this scope. Well, Andrea, it's your turn to explain the difference between safety and availability. Andrea, we have some problem with your audio.
My audio.
Okay.
It's better? Okay, sorry for interrupting you. So, because I had some question from attendees that my audio was not good, so I've tried with the headset, but it was worse probably. Anyhow, we try to be back. So we got some question about safety and availability, and that is also a topic point I see for you. But and we have tried to with this kind of configuration in our relays to look at both. Of course, safety is a must because IEC 61508, which is the normative we have to follow to be claim seal products, we have to take account about safety, not availability. But we have decided to, just to remind you, so safety meets a demand for functional safety, and availability is can be defined as the proportional time for which the equipment is able to perform its function. So availability is different from availability because it takes into account also the repair time. So an item of equipment may not be very reliable, but if it is can be repaired quickly when it fails, its availability could be high. Okay. So that is more or less the difference between safety and availability. What we did, if you see, those are relays, the two relays in parallel, in the series with the load, in series we have the two relays in parallel. And this is very interesting because it grants safety, but also availability. In case HFT, hardware fault tolerance, in this case 1, and if means that if one relay of out fails, still the safety factor is granted. Okay. And you will, safety factor will be won't be affected by a single fault relay. Okay, that was only one slide for me, and now I leave you again to Massimo.
Okay, Andrea, now we analyze some real application in relation to different types of load and the importance of the end-of-line resistors. Take, for example, a sound. Typically, those devices, especially in the off condition of the relay, show to the later a very high impedance, often outside the diagnostic range of the smart relay, or in the on condition of the relay, they show for a very short instant a full condition due to the capacity front end of the device. These problems often occur with these types of field devices, and to overcome them, it's necessary to insert resistors in parallel to the device itself, which allow us to bring the impedance value of the field devices with the diagnostic value of the relay. In other cases, however, these field devices, again, due to their strongly inductive or capacitive front ends, generate strong reverse current peaks, which risk irreparably damaging the relay contacts. To overcome this problem, it's necessary to insert protection devices such as PTC or power resistors, able to dampen this dangerous peak. As we see in the slide, these protection devices are placed in series with the field device, while the end-of-line resistors must necessarily be placed in parallel and as close as possible to the terminals of the field device. The values of these resistance or PTC must necessarily be evaluated from application to application based on the value of the load supply voltage. Well, the safety relays can be connected in different ways, in unipolar or bipolar configuration. A bipolar connection allows a complete isolation of the load, and this is recommended especially in applications where the load must be powered with high voltage. From an electrical point of view, this type of connection grants a great safety thanks to the complete isolation of the load. Instead, a unipolar connection isolates the load only on one of the power supply line and bring a negative to her in case of need. Furthermore, this type of connection saves a lot of cable cost. Well, only as regards the D5294S models, it's possible to configure the relay to have a diagnostic on the field device, even in condition of load connected in unipolar mode. Clearly, we must consider the bipolar type connection as is ideal and standard for an optimal functioning of the relay diagnostics. However, the D5294S guarantees, even if in a reduced way, a diagnostic of the field device connected in unipolar mode. It must be configured via software and connected as shown in the slide. In the on state, it will be able to monitor the current circulated in the load. In this way, it will provide us with information on the health of the field device and on the loop connected to it. With relay in off state, we will be able to monitor the power supply voltage of the load. Well, Andrea, we have finished the presentation of the smart relay.
Massimo, we have a question regarding especially the relays that you can see on the Q&R. And where the field device impedance is low, can the relay be configured for this example solve? Can you answer to this?
Yes, I remember to all that the smart relay, especially model D5294S, is totally configurable, and its diagnostic can be configured to be compatible with this impedance very low. In fact, the D5294S can be configured between an impedance and resistance between 5 and 50 kilo ohms.
The thing is that there are standard relays, standard solutions from us that cannot be configured. So in this case, that impedance would be always seen as, let's say, open circuit probably, no?
Yeah.
Because it's, oh, sorry, like in this case, it's low, so it's short circuit.
Short circuit.
Yeah, but if you use this kind of relay, where you can configure the resistance that you are reading, you can let's say configure that that value will be available for normal operation. It won't be, let's say, read as an alarm. So only the configuring the configurable relays like that can solve in some critical application. Okay, thank you. I see a lot of questions from attendees, and that's very good. I want to send again another poll. Probably if you want to answer, sorry, go back to this poll. And well, so, okay. If you want to answer, that is a multiple question. So you can answer to one or more answer. So what safety feature do you consider as relevant? So if you use safety relays, maybe you are experienced with different application and maybe different problems also. Okay, thank you. We can stop in a few seconds. So if you want to answer now, do it. Otherwise, we close and we go to the next things. Oh, good. So I see the most of you alarm contact and configurable threshold are the most important features. Okay, so let's go over with the presentation and we go for safety. So for the isolators and line monitoring, it's more or less my part. So just to remind you, we do have a wide range of AES isolators, so with a small dimension for different signal type and safety parameters. So we can say that we have an EOS system that could be wired by a single power bus system and optionally have a module for power redundancy, common fault reporting. Along with the CX certification, the modern application still is a requirement. The minimum CO2 is required nowadays for the applications. But the most important things and one feature that we are experienced with the people is the line monitoring. So beside the connection with the field, you wanna say know if your system, if your field device is having a problem. So let's analyze different line monitoring probably when using an AES isolator on your PLC DCS applications. So for analog input, 4 to 20 milliamp fluctuation will prove directly the presence of the line, and values lower than 4 milliamps or higher than 20 milliamps, it will indicate clearly that there is a failure. So the AES isolator reflects our up to from 0 to 26 milliamps transparently that value. So in case of lower than 4 milliamps or higher than 20 milliamps, that will be transparently reported to the system. And if the system can detect the failure, that will be indicated as a failure. So NAMUR compliant transmitter have a value lower than 3.8 milliamps, that is indicated as a failure, or higher than 21 milliamps, indicated as well. And the modules here, 5014, 5015, and so on, are, as I said, transparently reporting. They are not locked at a certain value, but they are they report from 0 to 26 milliamp the input current value. That is for analog input. For analog output is a little bit different because we have this module that can detect the 5020 pass, can detect both short and open circuit. In case of short circuit, when the low resistance detection is lower than 50 milliamp, sorry, 50 ohm or 100. That is a value in this setting over deep switches. The 50-20 reflect high impedance of the system side and forcing a current to 2 milliamps. So that could be detected as a fault if the system is able to read that as a fault. Okay. That is our indication from the modules. In case of open circuit, the load resistance is higher than the specific calculation, and high impedance will be reflected to the system as well. In this case, high resistance or high impedance to the system will be detected as a fault if the system can do that, can read that. Otherwise, there is a fault contact, as you may see from the slide, where the fault is clearly reported by opening a contact. For digital inputs, we have different solutions. So we have for 24 digital input card. So for 24 digital input card, normal condition, we see an equivalent resistance RH and RL. When the contact is open, so we are talking about the field side, when the contact is open, the output reflects the addition of those two resistance on the system side. In this case, the generated current understands that the field status is off. Okay. When the contact is closed, the parallel transistors that will close and the system will see only 2.2 kilo ohm. So we see only RL resistance when the contact is closed. The current to the circuit indicated on state. What happens in case of fault? In case of fault, short or open, the transistor connect in series. We open the circuit and a very high impedance will be reverted to the system side. So in this case, supervised digital input power can detect it. So there is this situation for normal 24 digital input card for normal contact that won't be detected normally if we don't provide such kind of monitoring waves. Of course, for proximity, the digital input card is different because we have a module, the 5034S, that is used as transparent module, and there is a current generator inside that reflects by different current values. You see from the table, the blue table there, and that the different status that reflect the situation in case of course, actually fault situation. The last is for digital out. Digital operates as analog out. Not big differences. When the load resistance is lower than 50 ohm or short circuit, high impedance and current at 2 milliamps will be forced to the output. However, when there is a load resistance higher than 10 kilo ohm, that means open circuit, the same high impedance and the current at 2 milliamps will be reflected to the output. And both, if the cards can detect that, is okay. Otherwise, there is a fault contact that can be used as an alarm in case of open and short circuit. So, if you don't see questions right now, we can go to the next part and the last part for this webinar with the power supplies, Massimo.
Okay, thank you, Andrea. In the next part of our webinar, we will treat the power supply system. Before going into the specifics of the operation of a safety power supply system, let's see a quick representation of the products offered by GMI in this field. The power supply safety system can be composed in a rack of up to 6 elements, each of which with 50 amps in 90-inch rack with onboard diagnostic module. Or alternatively, we can have a 9-inch rack with 2 50 amps power supplies on board, plus a diagnostic module, or again a 7-inch rack without a diagnostic module. All our racks allow the redundancy of the power supply module to obtain different working configuration. Finally, it's possible to obtain single module of 50 amps or 20 amps, which can be placed in parallel to have up to 10 modules connected in current sharing between them. Now, let's take a look at power supply. What are the possible risks and conditions that we are considered dangerous in relation to the use of a power supply? The concept of safety is very important also with regard to power supply system, because the failure of a power supply can cause serious accident to lead to serious losses in terms of human lives, serious environmental damages, and the serious cost losses for companies. For this reason, it's necessary to have safety devices that guarantee high performance. But what are the dangerous conditions for a power supply system? Well, there are two dangerous conditions. The first one is undefined load voltage in a range between 2 and 20 volts must be considered as dangerous failure of a power supply. This is because an incorrectly powered load works or can work out of specification, and this leads to a reduction in load performance that can cause a premature instrument failure. Often we try to avoid this issue using redundancy, but we wrongly think that 2 power supplies in parallel are sufficient to make us immune from possible faults in the power supply system. Redundancy cannot solve on its own and cannot guarantee us immunity from power supply failure, because a standard power supply system does not take into account the common fault that can afflict standard power supplies. These common mode faults can cause spurious system fault with the related production downtime, which would significantly affect cost. The redundancy of safety power supply minimizes this risk because common mode failure are considered in the SIL calculation necessary to get the certification for a safety-related device. The second dangerous failure condition of a power supply is when the output voltage reaches a value higher than 30 volts. In this condition, the load is subjected to extra voltage, which can damage it. Or in case of output voltage higher than 50 volts, the field instrumentation can suffer a definite disruption. Where we can take, for example, an engine cooling system which works thanks to a standard power supply. Suppose that this standard power supply fails and goes into an overvoltage condition, damaging the cooling system. This will lead to an overheating of the engine, which will lead to serious consequences for the whole system connected to it. A safe power supply system grants high performance and high safety. So why it's correct to use a safety power supply system? Below are the main reasons that lead us to advise against the use of a simple standard power supply. A standard power supply is not designed based on the directive of ESC 61P508. It does not have made a calculation defined for the safety function to be obtained. It does not allow to have a redundant protection from overvoltage issue. While in a safety power supply system, redundant protection are a fundamental requirement. And again, standard power supplies can be used in a redundant configuration, but they do not guarantee that our application is totally safe for the reason related to the common faults which we have seen previously. And also, standard power supply often require external O-ring diodes for redundancy. This means to have external wiring that, especially for high load currents, create a high voltage drop, which has a strong impact on the supply voltage. It's true that it's possible to adjust the output voltage to compensate for the voltage drop, but this operation increases consumption considerably. In addition, a standard power supply has a higher number of spurious faults than a safety power supply, and we know well how a spurious fault can also lead to dangerous failures for the application. And again, standard power supply use internal components with limited operating range to keep costs down. This affects the lifetime of the device. For this reason, internally to the safe power supply are used components with a higher operating range that allow the system to work at a lower stress level. This leads to less failure and consequently a considerable longer lifetime than standard power supply system. At this point, why it's important to use a safety power supply system? First of all, we know that the standard voltage for a normally energized load is in the 20-30 volt DC range. As we have seen previously, conditions that lead to power supply output voltage between 2 and 20 volt and higher than 40 volt are considered dangerous failures, which negatively affect the application. Well, a safety power supply significantly reduces undetected dangerous fault thanks to a built-in diagnostic system. In fact, if an anomalous output condition is detected by the safety power supply diagnostic, it brings the output to 0 volt, which represents the safe fault condition. Plus, a fault transistor alerts the PLC system, which can act as per C specification. Well, a huge advantages that safety power supply system give is the presence of the O-ring diodes inside the device. This grants a huge cost advantages, as it is not necessary to externally wire the diodes for each unit that is part of the redundant power supply system. GMI power supplies do not request external O-ring diodes for output parallel configuration because each GMI power supply has got internal an active ideal diode realized by MOSFET and the related control circuit components, replacing all metal with Schottky O-ring diodes. This increases efficiency, reliability, and availability, and reduces space about not used Schottky diode heat sinks. MOSFET active ideal diodes with related control circuit provides also very smooth voltage switchover without oscillation with fast turn-off, minimizing reverse current transient. Well, in the next slide, we see the mainly advantages that the ideal diode system inside the safety power supply system brings compared to a standard power supply. They mainly are, for example, voltage drop at 50 ampere. For the old system, we have 0.8 volt of voltage drop, while for GMI system, we have 0.06 volt. And again, the power dissipation at 50 amperes for the old system, minimum 40 watt. For the GMI system, only 3 watt. Well, the next slide, we talk about load sharing. This pure hardware control is complex and based on the output current measurement that each power supply module executes. Typically, load current sharing capability is necessary feature for medium and high load current. all GMI power supplies can be parallel on their output and their internal load current sharing circuit operate to distribute current load equally to each power supply module to increase reliability and reduce internal power dissipation of each module. Another advantage of load current sharing functionality is request of little system output voltage modification when two or more PS modules are normally operating. And the last important feature is the short circuit proof system. This system avoids that in the event of a shear short circuit of one of the loads connected to the power supply system, there is no system shutdown. In fact, when the protection circuit detects a short circuit on the line, it sends a current peak that can reach up to 800 ampere for a maximum of 0.5 milliseconds, able to interrupt the protection fuse or the circuit breaker associated with it, to interrupt the power supply to the short-circuited load and safeguard the rest of the system. Well, Andrea, we have finished our presentation.
Thank you, Massimo, and thank you to everyone. You can find further information on our website dedicated to the products we have seen. If you have any questions, if you have questions, don't hesitate to write now. Raise your hands. So there are few attendees who were very reactive this morning. Thank you for those questions. Some of them are very important for us. And we remind you there are other webinars on our website. You can find all details. You can register yourself. We are doing another one, Massimo and I, in February, more dedicated to the IS barriers, so don't miss it. Anyhow, you can find this webinar and others on our YouTube channel. There are all registration available. This one will be available soon, probably on Monday, not today. But there are the others that are also available. And so thank you. Don't have further things except the last call. Just please, you can just evaluate what you have seen today. Thank you. Don't worry, your name won't be displayed here. So just write what. Also, this is very important for our improvement, for our new webinars, and for the futures. Thank you very much. And thank you. I stop now. And I don't see further question from you. And we remind you our name and our emails. You can phone us, write us for further questions. Thank you, Massimo.
Thank you, Andrea. Thank you all.
We see soon. Thank you again. Bye-bye.
Bye-bye. Thank you.
Bye-bye.